Hello everyone! In this video I'm going to be talking about carry cancel adders and some extra complications. We're going to be skipping ripple carry adders for multiple reasons, one being that they are so incredibly slow, and the second is because it's easier to make carry cancel adders than ripple carry adders in my opinion. And we're going to start off with how they work. I'm going to have 4 pieces of wool to demonstrate, and we're just going to be adding 5 to 3. And I'm going to have this border right here just for decoration, and the operation, which is addition. So 5 plus 3. How are we going to do that? Well, if we were to ripple carry add, then we would have a carry line, and we would just AND these, and if they're both, then we do a 1 here. Then we check for this digit and AND these and put a 1. And I think you're starting to get the issue here. It just makes the carry a lot slower. So instead of doing that, we're going to be using a different method. This is kind of like carry look ahead. However, in Minecraft, there's a similar technique called carry cancel, which we are going to be using because it's pretty easy. Here, it's a 1 and a 1, and a 1 and a 1. If we AND these two, then we get a propagate signal, which is marked as green. And all of the carries after this will also be a 1 now. And we'll just continue on forever and ever and ever, just like that. So that's our carry line. However, we need to do one more thing. If the OR of these two digits is 0, for example, right over here, if we OR these two, that's going to be a 0. So we cancel this propagate, which in turn makes everything a 0 again. And this will go on forever. And that's our carry line. So if both of them are a 0, then the carry becomes a 0 and everything after that. However, if both of them are a 1, then we go with a 1, and that's what the carry line looks like now. Now what we're going to be doing is add our carry in bit, which is just going to be a 0 for addition. And now we want to XOR every one of these digits like so. So 1 and 1 is going to be a 0, then 0 and 1 is a 1 and a 0 is just a 1, and that's going to be a 0. There we go. Now what we want to do is we want to XOR the carry line diagonally. So this one is going to XOR this one is going to XOR that one. So our result will be 0 and 1 XORed is a 0, again a 0, and now 0 XOR 1 is a 1. So our result is going to be 8, and 5 plus 3 is indeed 8. Now I'm going to be showing off subtraction real quickly, and for that, this bit right here is going to be a 1. Now if I want to do 5 minus 3, then all you have to do is get 2's complement. So we first invert 3, which is 1's complement, but because the carry in is on, we already have 2's complement, so that was pretty easy. And then we just XOR again. However, the carry line is a little different. We have a 1, which means that all of the other ones are going to be a 1, 1, 1, 1, 1. Let's first just make the 1's, and I don't need these final bits actually, because they're not going to be used. And that, by the way, is our carry out. There are 2 zeros here, which means that we cancel. However, right here, there are 2 1's again, so we just carry on again. Now, let me get rid of this. Now let's XOR again. So 0 and 1 is going to be a 1, 0 and 0 is a 0, 1 and 1 is a 0, and 0 and 1 is a 1. Then we XOR these, so 1 and 1 is a 0, 0 and 1 is a 1, 0 and 0 is 0, 1 and 1 is a 0. And this one right here means that it is a positive number. So we have positive 2. If the result is negative, then it would also be in 2's complement, though this bit would actually say that it's negative. For example, if we do 3 minus 5, then we will get the 2's complement of 2, and this bit will be a 0. So that's pretty nice, because then we can just put it straight back into any addition without even having to turn on subtraction, because we already have the 2's complement, so we don't have to get the 2's complement again. Anyway, let's make a carry cancel adder. And before we can do that, I need to show off how a carry cancel adder does things differently from carry look ahead. Okay everyone, here is the carry cancel adder that we will be building. It's incredibly small in my opinion. And by the way, this final XOR right here is actually made by Benny's Cube. You should check out his channel, there will be a link in the description. The rest of it is not really that original. Almost all carry cancel adders look like this if they're 4 ticks. By the way, it only takes 4 ticks to process any data. And one extra thing, the output of this redstone dust, it's possible for it to only be a signal strength of 2. Anyway, let me show you it in action. As you can see, the input just flows right through. If I turn on all of these, then we have 255 right here. If I then turn on the carry in, then it's going to go to the carry out. As you can see, If it was a ripple carry adder, it would do like 3 seconds per bit. It would be incredibly slow, but this one calculates them all in parallel, which makes it a whole bunch faster. And the same goes for the folding edge. There we go. Okay, so let's build this guy. It's pretty easy, not gonna lie. It's just that you need world edit in order to stack it. So we're going to start off with an XOR. It's not very surprising. And there's actually a problem that we need to face, and that is, how do we carry on this one for every single bit after it, and then just block it, and then block it all the way through if there was no generate again. Well, for this we're going to use a carry tower, and you've, well, already seen it over there, and I'm just going to build it. For it I'm going to be needing... Narrator. Why is my narrator on? Hang on. Narrator. Okay, I hope it's off now. Anyway, we have a... Narrator. What? Okay, I hope it doesn't do it again. Anyway, we're going to have a torch here, just like over there. And this will act like our AND gate. Now, you'll be like, what? We are literally just taking the XNOR. How is that an AND gate? Well, apart from when both outputs are 0, if one of them is on, the AND gate is off. If both of them are on, the AND gate is on. So it kind of works like an AND gate. We just need to cancel out the signal if both of them are off. And we can do that by taking the NOR, like so. And then we want to make slab tower right here. And it's just going to go up and up and up. And that's how we carry the signal. Because if I power it over here, then the redstone dust won't go down. Now we need an output for the carry. And we can do that like so. Now there's actually a problem that isn't a problem, and that's that this repeater powers the AND gate signal. However, because of the way that comparators work, it actually solves the problem again. It's kind of weird. Let me show you. So if I have one on, then this is the carry line, by the way, then there's no output. But if both are on, there you go, 2 carries. Now we only want the bottom one to be on, so what we need to do is just power this, and this will already happen because there will be a torch there which turns it on right over here, and that's how we block it. So even though this dust right here turns on, it also cancels it, and this is just 50 minus 15, and that's 0. By the way, even if we go one up, it will still cancel it because both signal strengths will be subtracted by 2, as you can see right here. There you go. Actually, let's keep that. Now we're not going to put our lamps here. This is just the carry tower. We need to hook this up to another XOR. So we already have calculated the carry, which is amazing. It's really that simple. We're going to be changing the bottommost module in a second, and I'll tell you why in a moment as well. But before we do that, let's just make the simple version. So we put our next input over here, and here we again take the XNOR instead of the XOR. And the reason why we do that is because of the next XOR. It's kind of annoying to have to say all these logic gates names every single time. It may not make sense, but don't worry about it. Anyway, we're going to have a comparator here with a dust like so, and then we want a torch with a dust on top, and we want a dust over here as well with a block here, put a dust here. It's quite a mess, but it does work. It's a working mess. Alright, this dust line needs to be on as well, so just power it like so. And yeah, I think we can stack it now. So we currently have 2 bits and we need another one under it. So we built the same XNOR. And we put a repeater, dust. It's the same principle, except now we need a repeater here with a redstone torch. And that right there is supposed to be a block. Like so. And let's just fix it right now, actually. What I'm going to be doing is getting rid of that torch over there. And then I'm going to put a extra dust over here. So this dust right here will have a signal strength of 2, so we can have a maximum of 2 pieces of redstone dust. And then we can get rid of this block and put a torch here, which goes into the carry tower. Then we can get rid of this slab. We have to keep that as slab for stacking purposes. And then I can have, hang on, my carry in right here. And I needed the dust right here for it to work, and also this. Now the reason why we needed to redirect this torch to some other place is because else the carry tower will run out of signal strength before it goes to the final carry out bit, which we don't want because then we don't have a carry out bit. Okay, let's carry it. Let's stack it now. So we select this block right over here. Then we select this block next to the redstone lamp and we stack it 6 up. There you go. And now we want to add a repeater, and here it would have lost its signal strength. Here it will be 0, but because of how we made it, it now luckily reaches. So we're just going to add this final little piece of redstone. There you go. Okay, let's test it. Let's see if it works. So let's put in 255, which is just all the bits, because it's 8 bits. There we go. And then let's turn on the carry. There you go, it works. And this works as well. Great. So that's our carry cancel adder. And if you want to do subtraction, you just have to turn on the carry in. Invert all of these, which we will just simulate by turning them all on. And after that, let's do 5 by turning on these. And then we put in 3 is just by turning them off. So this will be 3. And that is 2, and it's positive because the overflow bit is on. Now we can also check if it's negative by just inverting it. No, not inverting it, by actually just powering it from this bit, not from this one. Checking if the number's even is also extremely easy. We just check if this one is not on. There you go, that's our even flag. Now later on we will turn this into an ALU, but I think it's fine for now. And by the way, an ALU is an arithmetic logic unit, and it does more than just addition and subtraction. It also includes shifting, ANDing, XORing, ORing, and all of the other logic gates. Though we will simplify it by only having AND, OR, and XOR, and then just have a invert at the end of this ALU. But yeah, that wraps it up for carry cancel adders. If you have any questions, ask them in the comments below. Make sure to subscribe and like this video. And in the next video, I will be talking about multiplication and division. So yeah, thank you guys so much for watching, and see you in the next one. Bye!